Hello, I am the marooned Mr. Daycock, and today I'm going to be teaching you about arithmetic sequences. So, first question, what's an arithmetic sequence? Well, an arithmetic sequence is a sequence like this. So, say we had 3, 8, 13, 18, and 23. It's a pretty basic sequence. Nothing too much to it, but it has basically one key feature that makes it arithmetic, and that the difference between consecutive terms is constant. So if I take term 2 here, and I subtract term 1 here, then I get 5. It's 8 times 3 equals 5. Equally, u3 subtract u2 is going to be 5. u4 subtract u3 is going to be 5. And that's the definition of an arithmetic sequence. And as such, what we do for any arithmetic sequence, we define two key constants. The common difference, which we label as d, which in this case is 5, and there are lots of sequences that have a common difference of 5, so we also need to define the first term, which we call a, and in this case it would be 3. So this completely defines this arithmetic sequence. Given you know it's arithmetic, having d equals 5 and a equals 3 gives us a complete definition of it. So let's look at what it would be if we just wrote a general arithmetic sequence in terms of a and d. Well, the first term would be a. So our u1 would be a. Our u2, our second term, well, that would be a plus d, because we need another d added on. And u3, well, we started at a, then we got to a plus d, and then we needed to add another d on, because that's our definition, isn't it? Here, every time we add on 5, every time we add on 5 up here, so every time here we're adding on d because we're doing the general form. So we add on another d and we're going to get a plus 2d. And the next one we're going to get u4, which is going to be working out as a plus 3d. And then u5 is going to be a plus 4d. And now we should be noticing a pattern between the term number, our n being the term number, and these expressions. They all have exactly one a, so we can write this down. Un is going to be equal to a, they all have exactly one a, plus, and notice here that the term number is one more than the number in the sequence. Therefore, it's a plus n minus 1 d. And that's our general term here for an arithmetic sequence. Okay, so let's use that. Find an expression for the nth term of the arithmetic sequence 3, 15, 27, 39, etc. So first of all, a is going to be equal to 3. And what is d? Well, the common difference, 15 take away 3 is 12, 27 take away 15 is 12, our common difference is 12, and therefore our nth term is going to be a, so un equals a plus n minus 1 d. But now we know a and d, so we got un is equal to 3 plus 12 lots of n minus 1. And therefore, un is equal to 3 plus 12n minus 12. And so we can write this as un is equal to, well, 3 minus 12 is negative 9, 12n minus 9. Same thing here. Our common difference, well, our second term is 30 and our first term is 34, so our common difference is 30 minus 34, which is negative 4. So our common difference is negative 4. Our first term is 34, and so again we just apply exactly the same thing. We get un is equal to 34 minus 4 lots of n minus 1, which is equal to 34 minus 4n plus 4, which is 38 minus 4n. And there we go. Two expression for each of our given questions, our given sequences, using the formula. Okay, often the questions will be a little bit more complicated than that. So let's look at the nth term of an arithmetic sequence is un. Given that u3 is 11 and u9 is 25, find an expression for un. So we're going to use that same formula. We say un is equal to a plus n minus 1d. And we're going to plug in what we know from each one. So from this one, we know that u3 is 11. So what we've got here is the value on the left-hand side. We get u3, which is 11. And we know n. So we get a plus 3 minus 1d. Similarly for this one, we're going to end up with 25 is equal to a plus 9 minus 1d. And doing a little bit of simplification, we get 11 equals a plus 2d. Here we get 25 is equal to a plus 8d. And now we've just got a case of simultaneous equations. If I do equation 2 subtract 1, equation 2 subtract equation 1, we're going to end up with 25 take away 11 is 14, is equal to a take away a 0, good, and 8d subtract 2d is going to give us 6d. So just applying standard simultaneous equations there. And then we divide by 6 and we get d is going to be equal to 14 over 6, which is equal to 7 over 3. Okay, and then just plug that back in. We're going to get 11 is equal to a plus 2 times by 7 over 3. So 11 is equal to a plus 14 over 3. We're going to subtract that 14 over 3 and we get a is equal to 33 over 3 subtract 14 over 3, which is going to be equal to 19 over 3. And there we go. We have our arithmetic sequence. Our arithmetic sequence is un is equal to a is 19 over 3 plus, and d is, where is it? 7 over 3. 19 over 3 plus 7 over 3 lots of n minus 1. And then to simplify it, we can get un is equal to 19 over 3 plus 7 over 3n minus 7 over 3, or un is equal to 12 over 3 plus 7 over 3n, which is un is equal to 4 plus 7 over 3n. And there you have it. That's our arithmetic series in a nutshell. Thank you very much for watching, and I'll see you in the next video. We'll be looking at arithmetic series, which is a bit of an extension from this, and it requires a little bit more thought about what we're going to be doing. Thank you very much, and I'll see you in the next video.